Good afternoon, everybody. So, as you are probably aware or have been reminded by now, I am not here for the whole week as I am away on parental leave. So, here's what this week will look like for you. Tuesday, Wednesday, Thursday, Friday. So, Tuesday, today, we will be completing day 3, composite shapes. So far in this second unit, geometry, we have covered area and perimeter, and surface area and volume. Today we're going to look at composite 3D shapes. You will have a paper copy, you should anyway, at this point, for day 3, unit 2, composite volume of prisms, pyramids, cylinders, cones, and spheres. Now, so long story short, what this week looks like is you will have a worksheet on Tuesday to complete with an accompanying video. Wednesday, you will have one as well for day 4, optimizing area and perimeter. And you will have another one on Thursday, day 5, optimizing surface area and volume. On Friday, all 3 of those worksheets will be collected and submitted like I normally would on any other given day. Friday will just be a catch-up day for you to complete any of the 3 previous worksheets you have not already completed. But obviously, if you use Tuesday, Wednesday, and Thursday wisely, Friday you could have minimal work to do. And I'll mark them over the weekend and have them ready for you for next week, next Monday. Now, couple things. Even though I am on parental leave, I'm obviously not sick. I'm just at home helping out with the child. But I will be making phone calls this week when I can. So pay attention to your D2L mark and pay attention to what you're missing. For students who are missing the tests, and there aren't many of you, maybe 2 or 3, I have given the supply teacher copies of your tests, blank copies. Feel free to go over to resource to finish that up. For the assignment, and I do have a good chunk of you who have not handed in the assignment just yet. Again, just a reminder, there are 2 elements to it. Number 1, the package that you have, the assignment package. Number 2, the floor planner bit that you can email to me. You will see on D2L under grades that there is a temporary 0 put under the assignment. It's just to show you that, hey, it's already due, but you can still hand it in whenever, and that mark will change. Now, I know I said this a few times already, but projects and assignments are worth the most in this course. So if you saw your mark plummet, that's why, because we've only done 1 assignment. Once you hand it in, your mark should go right back up to where it was before. Obviously, if you do okay. For those of you who have already handed in, you should be able to now see. Let me just view a student. You should be able to now see your trig assignment mark right there out of 30. Okay. Obviously, you should also see your test mark, class completion, which is these worksheets. Your warm-up and exit books obviously are not going to happen this week, so ignore them. And your 1 trig quiz. Okay. All right, so let's get started on today's stuff, which is composite 3D shapes. You know what? Give me 1 second. It might be better if I work in PDF. Okay, so today our focus is looking at composite figures. So in other words, we're looking at 3D composite shapes. Okay, so you will need this formula sheet. So I would advise that you take it out unless you have some of these formulas memorized, but you're not expected to. So let's start. So how do we calculate composite figures? You calculate the volume of each part of the object, add up the volumes, and subtract the volume of any parts that are removed. So let's start with this cone. Composite shapes are usually shapes that don't have a unique name, but they are made of other shapes that we are familiar with. For example, an ice cream cone is a cone with a hemisphere or half a sphere. So how much ice cream is here, assuming the cone is filled with ice cream? Of course, this never happens. Our cone is never actually filled with ice cream. There's always air pockets, but let's assume that it is. So our job is to find the volume of the cone. So the volume of the cone would equal to the volume of the semisphere or half sphere, hemisphere, plus the volume of the cone itself. Okay. In fact, I'm going to color code this to make it a little bit easier. So here is the cone. Okay, and the volume of the cone. So let's start with the hemisphere or half a sphere. So here's a sphere, and now are we looking at surface area or volume? We're looking at volume because we want to know how much ice cream is there, right? So the volume, so I'm going to do it on the side here. The volume of the hemisphere, I'm just going to put H, or the ice cream, would be 4 pi r cubed divided by 3. So 4 pi r cubed divided by 3. Okay? Now, let's calculate this first. I know I need to divide by 2, but let's just calculate this first to get a number and then divide by 2. R represents the radius, which is half of 7, and half of 7 is 3.5 cubed divided by 3. Now let's type all this in my calculator and see what we get. So 4 pi and then 3.5 cubed, all that divided by 3, 4 pi, making sure I typed everything correctly, 179.59 centimeters cubed. Because we're looking at volume. But of course I want half. I only need half, right? Because this is only half a cone. Or half a sphere, sorry. So then I'd take 179.59 and divide that by 2 to give me 89.79, so 7. So let's say 89.8. So 89.8 centimeters cubed. So this would be 89.8 centimeters cubed. Now let's go with green and look at the cone. So what's the volume of a cone? I'm going to do that down here. So the volume of this cone would be, if you look back at the formula sheet, volume of the cone, pi r squared h times divided by 3. So volume equals to pi r squared h divided by 3 is equal to pi r, and the radius is still the same, right? They share the same radius. So 3.5 squared, and the height is 10, divided by 3. So let's see what we get here if I type this all into my calculator. So that's pi times 3.5 squared times 10 equals, divided by 3 equals 128.28 equals 128.28 centimeters cubed. So this would be plus 128.28 centimeters cubed. So the volume of the entire thing would equal to, those two numbers added together, 0.8 equals 218.08. 218.08 centimeters cubed. And we are done. Okay? So all we have to do is look at the object. So you have 1, 2. Ooh, that's not good. Number 4 you might not be able to do. because that is very blurry. So give me 1 second to check number 4. Oh, why did it show up like that? Looks fine here. So I am hoping that it looks normal on yours. I don't know why it turned out like this on my PDF, but I'm hoping that the printout you have this. And if you don't, use this picture as your reference for number 4. So for the rest of these questions, what you have to do is find the two shapes that make up the object. So for example, number 2, how much air is inside this empty house, which is made up of a rectangular prism base and a triangular prism roof. So the two shapes are, you can see that is the, let me just go back to triangular prism, which is right there. Now the question is, looking at that prism, are we looking at volume or surface area? Well, since it's asking about air, we're talking about volume. So we're looking at volume of a triangular prism, which is right there. Here's the formula, BLH divided by 2. And at the base, this is a rectangular prism, which is right here. And again, looking at volume, which is just length times width times height. Number 3, pineapple can be bought in sliced rings that look like the sketch provided. If the outer ring has a radius of 7, so which means from here, so from here to here, this is 7, and the inner ring has a radius of 3, which means from here to here, so this little section that I'm shading right now is 3. Find the volume of the pineapple slice. So in this case, it will make sense for you to find, let's pretend this is pineapple, and with 7, okay, without the hollow middle cutout. So find the volume of the entire thing, volume of the pineapple without the hole. And then it might be a good idea to find the volume of the inside, which is the hole you're going to cut out. So this would be the volume of pineapple hole, I guess, and subtract the 2 to find the volume of the actual pineapple that you have. Number 4, this shape is called a frustum. It is a square-based pyramid with the tip cut off. Find the volume of this frustum. So of course with this one, you can use the volume of a triangular prism, which is right here. And then once you find the volume of that, then if you notice the tip that's cut off, isn't that just another smaller pyramid? Sorry, I lied. You're not using the volume of a prism. You're using the volume of a pyramid, which is right here, square-based pyramid. So that's the formula you would use for the big pyramid, which is this one right here. So find the volume of the big pyramid, then find the volume of the small square-based pyramid and subtract the 2. Number 5. 3 tennis balls are packed tightly into a cylindrical container. The diameter of one tennis ball is 1.7. So from here to here is 1.7 inches. Determine the volume of the space in the container that is not taken up by the tennis balls. So what you need to do here is find the volume of the cylinder, okay? Then find the volume of each individual tennis ball. Once you find one, just multiply it by 3. And then, so all you need to do is find the volume of the cylinder minus the volume of 3 tennis balls. Okay? And the last question, and I feel like I'm giving you way too many hints, but that's okay. So we've got a shipping tube that ships 3 packs of soccer balls and is made from a cylindrical center with the hemisphere at each end. Calculate the space that is inside the container. So we're looking at the space that's inside here. So a shipping tube that ships 3 packs of soccer balls is made from a cylindrical center with a hemisphere at each end. Hemisphere, so half sphere on each end. Okay. So 3 soccer balls fit in here. So 1, no, that's obviously a bad image. 2, 3. Okay, so that's the idea anyway. Calculate the space that is inside the container. And pay attention to the units. Okay, and that's it. So there's only the 6 questions, and I did one already for you. Okay, I did the cone one for you. All right, I'll see you guys tomorrow. If you have any questions, as always, you can ask the teacher, ask the supply teacher, or if you get stuck, you can email me at jtram@scudsby.on.ca.